All right, so the method we've looked at, the simple way of solving exponential equations, equating the bases. So taking a problem like this, 2 to the x power equals 16, and writing both sides of your equation to the same, with the same base, so 16, how can we rewrite 16? Well, 16 2 to the fourth, so therefore, we rewrite 16 as 2 to the fourth. The same base means the exponents have to be equal, so x is equal to 4. What if we get problems, though, where we can't equate the bases? So this is the one I warned you about in class. 4 to the x equals 15. Well, 15, if I wanted to rewrite that as 4 to some power, generally the powers are supposed to be ones that you can kind of think through logically. They're not going to be crazy large numbers or weird fractions. 15 is 4 to some power, certainly, but we don't really know what power that would be. This is where the method comes in, that we're going to need to do something a little different because we can't actually make the bases the same. So the steps are, and we're going to get some slightly more complicated exponential expressions, so equations. So the first step is to isolate the exponential expression. So in other words, get the base and exponent alone. So figure out what base. We have a base in for this problem 4 with its exponent. The power is x. If there was anything else included in this problem, so say there was a 7 plus 4 to the x power, the first thing you want to do is isolate that exponent portion. Get the 4 to the x power all by itself. Second part, and we'll see how this works out, is we want to take the natural log of both sides of your equation. So right now we're just going to go through the steps, but take the natural log of both sides as step 2. And you see why we do the natural log as we do a couple problems here. Simplify, and we're going to simplify using properties of logs. So the properties of logs that we've covered was if you have the log or natural log, it doesn't matter which one, of a number, some number to a power. Remember that power is actually, you could rewrite it as multiplying the log. You can move that power out front of your log. The other property we'll use to simplify is very similar, and it's just a special case, and this is kind of why we use logarithms, or natural logs, because it'll help us do this a little more easily. But if we take the natural log of e to the x, if you remember what natural log, it has the base of e. So you're asking yourself, e to what power equals e to the x? Well, the answer has to be x. So those are the two kind of properties we're going to use to make this simplify a little bit more easily. And then the last step, if necessary, we want to solve for the variable. So let's look at the problem we just went through. Step 1 is isolate the isolate the exponential portion. So isolate the base and the power. So base and the power all alone already. There's nothing that needs to be done for step 1. We move on to step 2. Step 2 is to take the natural log of both sides of the equation. So natural log of 4 to the x, and take the natural log of 15. The advantage to this, and the real thing we need to realize is, if we're saying 4 to some power equals 15, it's not going to be a nice even number. The advantage to doing it this way is that we get things that we can easily type into our calculator. So if you type in natural log of 15, you're going to get a number that, you're going to get a decimal out. It's not going to be a pretty number, but it will be a number. So step 2 was take the natural log of both sides. Step 3 is use those properties. So either, and we don't have e to a power here, so we're going to be using the property where the exponent can be written out of the log. So we're going to write ln of 4 to the x as x times ln of 4. So we use that log property. And now step 4 is solve for the variable. Get the variable alone. So how do we get x alone here? Well, we're going to ln of 4, natural log of 4, if you typed it in your calculator, is just a number. So we're going to type it into our calculator in a second here, but first, to get x alone, you need to divide both sides by the natural log of 4. Realize it's just a number. Natural log of 4 is a number. It's not a pretty number, but it is just a number. So x is going to be equal to the natural log of 15 over the natural log of 4. So if I bring my calculator back in here, and we say natural log of 15, make sure you close your parentheses, divided by the natural log of 4. Not a pretty answer, but that's the power, 4 to the 1.9534, and we'll just round it to hundredths. Power would be our answer. So x is about 1.95. So let's look at slightly harder versions of the same kind of problem. So 9 e to the x equals 107. So again, something that's not going to work out nice and evenly, but if we go through our steps, step 1 is isolate. So what you want to say to yourself, okay, what's the base on my exponent? There's not two pieces to my base here. The base on my exponential portion is e. I want to get that portion all by itself. So how do I get e to the x all alone? Well, I need to get rid of this 9, so I need to divide both sides by 9. E to the x equals, and 107 divided by 9 is of course not a very nice number, but I'll leave it as 107 over 9 then until we get to our final answer. So first thing, get the base and the exponent alone. Step 2, take the natural log of both sides. And if you see an exponent, if you see an exponential equation that has e in it, this is the reason we use natural log. Natural log of e to the x equals natural log of 107 over 9. Step 3, use the properties. So the property we have here, because we have e to the x power, natural log of e to the x is just equal to x. So we want to simplify using properties we already know. X equals, so ln of e to the x is actually the same as just x. And step 4 is solve for x. So in this case, all we have to do is type that into our calculator, which I'll go ahead and do for you here. Natural log of 107 divided by 9. So about, x is about 2.4, and I'll round to hundredths, 2.48. So you're looking for not pretty answers, but natural log is going to lead you to the ability to find them. All right, let's check out one more question here. 40 times e to the 0.06x minus 3. So again, thinking through our steps. What's the base? The base that you see with your exponential here is just the e. So you need to think, how do you isolate that? And if it helps you, think of this as a problem, not as e to the 0.06x. Think of it as just replace the whole thing with x if you forget which steps to do first. So how do you get x alone? It's the same steps you're going to follow. So for number 1, we want to isolate. In this case, we're isolating 0.06, or e to the 0.06x. So we're going to add 3 to both sides. 40 e to the 0.06x equals 240. And then to get rid of the 40, we're going to divide by 40. E to the 0.06x equals 6. Okay, we've got it alone. We've got the exponent part alone, the base and the exponent alone. Step 2, natural log of both sides. So natural log of e to 0.06x equals the natural log of 6. And remember, whenever we say natural log of a number, it's purely, it's just a number. It's not a pretty number. So natural log of 6, oops, typed it in twice. Natural log of 6 is 1.79. So not a pretty number, but it is a number. So we need to do step 3, is use our properties. So natural log e to the x equals x. So in this case, our exponent isn't just x, it's 0.06x, but we can kind of use the same idea. The natural log of e to any power is just going to be equal to that power. So 0.06x equals the natural log of 6. Step 4, solve for x. So divide both sides by 0.06. So on our calculator, divide by 0.06, and x is about 29.86. So the nice thing about this method is that it will work on any equation. So if you want to use this on, and it might be a decent idea, try some of those equating the bases questions using this method. It'll work just the same, and maybe some people think this method requires a little less actual work on your part. So this is our method, our main method, kind of like quadratic formula for solving any exponential equation.